Welcome to another lesson, and we're talking about SI fuel systems. And ideally today I want us to talk about manifold designs, but before I do that, I'd like us to recap on what we had talked about. So previously we have talked about the SI fuel system layout. We've seen the gravity feed as well as the pressure feed. We also looked at fuel pumps, both the mechanical and electrical fuel pumps. We also saw the simple carburetor, its construction and its operation. And then we looked at the biggest downside of the simple carburetor, which is in that it only gives a correct mixture at only one given speed. Consequently, it means that to correct this, a few adjustments have to be made to the carburetor, which is why we talked about the methods of mixture correction. And these ones include air bleed compensation, compensating jet, an accelerator pump, economy devices, idling system, and enrichment devices. You remember very well, we talked about the enrichment device being one, something similar to what the accelerator pump does. We then took a look at the complete carburetor, which is now the constant choke carburetor, which can either be the simple barrel or the single barrel or the twin choke carburetor. Now this is the carburetor that has a fixed venturi, but the depression varies according to the airspeed. We then looked at the variable choke carburetor, which is also called the constant depression carburetor, which has a horizontal lying air tube, and then perpendicularly we have the piston, dampened piston, that acts as the venturi or controls the size of the venturi to give us a constant depression. Now today I want us to talk about manifold systems. And when you talk about a manifold, we mean talking about a tube that collects airs and then distributes it to respective cylinders. We can also have another tube that collects exhaust gases and dispenses them out through the exhaust system. So we shall try and talk about the inlet manifolds, exhaust manifolds, how we clean the air that comes to the engine, and lastly we'll talk about exhaust silencers. So as far as the inlet manifold design is concerned, its function is to distribute the fresh charge of air and fuel to the individual cylinders of a multi-cylinder engine, and in diesel engines we only distribute the fresh air supply. So it must be very important that the distribution pipes be of equal length so that we treat each cylinder equally and give it adequate charge or a balanced charge to make sure that they all have the chance to produce the same power. Now the factors that influence the manifold design include: one, airflow. So to obtain the best airflow of gas into the cylinder, the design should be of a large diameter and all the bends should be gentle, no sharp corners. The pipes of the manifold also not to be too long, and the length of the pipe from the throttle body to the cylinder should be equal as much as possible. So from where we have the distributor, when we have the carburetor or the injector nozzle, the length of the pipe to the cylinder head should be as equal as possible. Now, use of variable length manifolds is now common to ensure that correct gas pressures are maintained over a wide range of engine speeds, and we're going to look at this next. Now, the other factor that considers the design of the manifold is the behavior of the fuel spray. Now, the presence of fuel atoms in the passing air in the manifold is responsible for most of the difficulties on manifold designs. Remember that air-fuel mixture, we have particles of molecules of fuel that are carried in the air. Now, the fuel is denser than air and thus resists more where there is a change of speed or direction. Air will always respond faster than the fuel. Now, unless the speed of flow of the mixture is kept very high, the fuel tends to settle on the floor and the walls, and the mixture becomes leaner as it gets to the cylinder. So it is therefore required to reduce the cross-sectional area to maintain a rapid flow of the air. And this design contradicts with what we said with airflow. We said for good airflow we require a larger diameter. So we must arrive at a balance. Now, the factors then that influence the fuel suspension in the air, or how the air or the fuel is carried in the air, is one, the fineness of atomization of the fuel. So the finer the atoms of fuel, the better they will be carried in the air. The pressure or depression in the manifold. The higher the depression, the better the atomization, because that is what actually draws the fuel and breaks it up downly. And thirdly is the temperature of the mixture in the manifold. Remember, we said that we atomize the fuel first and then it absorbs the heat from the manifold to vaporize. Now this brings the need that to heat the air to achieve vaporization and improve the suspension of the air in the mixture while reducing the possible weight that can be induced in the cylinder. That is the volumetric efficiency. Now, the features of a good manifold are: one, a suitably sized pipe to maintain reasonably high mixture speeds at low engine speeds. Two, to introduce corners rather than gentle bends where changes in directions occur. Now, the turbulence created at these corners will assist in keeping the fuel in suspension in the air. And three, a fairly short manifold to avoid marked gain in power at one speed at the expense of a marked loss at another speed. And lastly, there must be some means of applying heat to the manifold walls. And we look at this, what we're calling manifold heating, because we say that we require to heat our manifolds for us to be able to achieve better atomization. Now, heating of the manifold can be done in two ways or three ways. One, conduction from the cylinder block through the manifold gasket. That is where the manifold gasket or where the manifold is attached to the block or the cylinder. Then heat can be conducted through to the metallic parts of the manifold, and then the heat is acquired. Or two, conduction from the coolant circulated through a jacket that surrounds the intake manifold. In some instances, you find manifolds that have connection to water jackets, and coolant is allowed to circulate through the manifold to give us inadequate heat for vaporization. Three, we can use electrical heater that can be located in the intake manifold. I want to just show you some bits of what we call hotspots. I'd like you to read further and look for the other two, where water is used and where an electric heater is used. But here I want to show you a method of conduction where you intentionally create a spot that is hot by using exhaust gases to exchange heat as they leave the engine and transfer heat to the inlet manifold. So we have two types. One is called a well type and the other one is called a controlled type. Now in the well type, we have the upper part here being the the inlet manifold, and we have the air coming in from the charge coming from the carburetor flowing downwards. Let me take a pointer here, flowing downwards through that point and into the ports, while the intake manifold is connected to the exhaust port. So they are shared, they are on the same side, but they are separated by a membrane or a plate here. So the heat from the exhaust manifold will come and conduct to the plate and go to the other side without necessarily mixing. Now our well here has a bend, and because of the weight of the fuel particles, they tend to settle down here, and if they condense, then they trickle down through this hole and enter what we're calling the vaporizing chamber. The vaporizing chamber has a drain that is ideally fitted at somewhere midway between the vaporizing chamber, so that in case we have excess fuel that has condensed down here, then it drains out. But when the vaporizing chamber heats up, then the fuel particles will vaporize and enter through the hole and go to be burnt. At the same time, when the vapor is rising up here, then air fills in and allows the fuel to go into the mixture. Now on the other hand, we have a thermostatically controlled hotspot. It is similar to this, only that it can be controlled in that once the engine warms up, we no longer require to heat the intake manifold. So we have a bimetallic strip that controls a lever here. So The upper part again is the inlet manifold, and air passes through that way. But the inlet manifold has a jacket around it which the exhaust gases can occupy. On the lower hand, we have the exhaust manifold. Now the exhaust manifold, the gases are flowing in that direction and moving outwards. So the position of the valve here can give us two parts. One is when this path is blocked here, when the engine is cold, or when we have condensation during cold time. When the engine is cold, this valve can be closed here by the thermostat, and the exhaust manifold or the exhaust gases are forced to pass in upwards and go around the water jacket, or other jackets here, and warm up the intake manifold, making the mixture to vaporize well, and then they leave that way in the longer path. But once the engine has warmed up and you no longer require to heat up the manifold because we have now conducting enough heat, then the thermostat allows this valve to be opened, and then it lies across here straight, making sure that the exhaust gases no longer pass up into the jackets, but the exhaust gases take the shortest route that way, as can be seen by the small dots. That is the hotspots. Now I want you to look up and see where electric heaters are used, and especially on the Hannah and Helia book, and also look at those ones that are heated by coolant on the same book. Now typical manifolds are seen like this. We can see a manifold that serves 4 cylinders. The C here stands for the carburetor, and then the valves are arranged this way. You have the exhaust valve here, inlet, 2 inlets, exhaust, inlet, exhaust. So this air we can distribute this air with equal lengths of tubes from the carburetor and charge the cylinders equally. The alternative is to have 2 carburetors, a carburetor serving 2 ports and a carburetor serving another 2 ports here, connected by a balance pipe. Alternatively, we can have a Siamese pipe here that has 1 carburetor, and then we have 4 ports. This is more common. We have 4 pipes serving all the 4 ports. Or we can have 2 carburetors, each carburetor serving 2 ports with 2 distributor pipes. This is another design that has a resonating chamber underneath the carburetor, and we have a unique design of shorter pipes serving the 2 cylinders in the middle, and 2 longer pipes serving the 2 valves in the end. This one has 2 carburetors with a similar design. Look at another design here that can be used with a engine that has a V arrangement. You can have 2 banks or 2 pipes, each serving 2 banks. You can have A and B, that's an intake A and intake B for a twin intake, or you can have this one that can be used again for a V8, showing the intersection of how the air flows. Now next I want us to talk about air cleaners. Why do we need to clean the air that comes into the engine? Now the air consumed by the engine must be kept free from dust to prolong the life of the pistons, piston rings and cylinder bores. So you'll agree with me when you say that the air that surrounds us is full of dust. When you try to clean your nose in a handkerchief in the evening, you always find evidence of dust in your nose. Where does this dust come from? These are dust particles that flow in the air. So if you allow this kind of air to go into the engine, it is likely to cause abrasion, because dust contains sand particles which are very abrasive, and they increase the wear of the cylinders, the pistons and the piston rings. So to prolong the life of the engine, we need to make sure that the air going into the engine is clean. Now there are 2 types of air cleaners used. We have an oiled mesh or a paper element type. Now the noise produced in the intake system is sometimes due to the vibration of columns of air and is known as resonance. Now the silencers are responsible to damp down the frequency of these vibrations to a level that the human ear cannot detect, and they usually consist of tubes tuned to a particular intake system. So nowadays you'll see air cleaners with boxes below them or pipes below it with funny shaped containers. These are containers that are used to kill out the pulses that are created by air, or the columns of air as they are drawn into the engine, or called resonance. And sometimes it can be very noisy if we are to draw air directly. Now let us look at the paper element air cleaner. It consists of a casing, and inside the casing you will find the paper element. This is like a felt-like paper, and the paper is folded or pleated to increase the surface area. This is on its section, so the paper would cover around. You may have air cleaners of any type. You can have rectangular ones, square ones, cylindrical ones, or cuboid ones, depending on the design of the vehicle. But the most important thing is to have a large enough surface area to match the amount of air that comes to the engine. Now, dirty air is forced to pass through the air cleaner from the outside or the peripheries, and dirt particles are cleaned out, and then air passes through the center column and into the main air tube and is charged into the engine. Now, it is very critical that you have seals below the air cleaner and on top of the air cleaner, or where you have the lid, because should you put an air cleaner without lids, then air will always take the path of least resistance, and it will bypass the air cleaner that has some resistance and go into the engine. Now, similarly, when the air cleaner becomes choked, your engine starts to starve of air, and it is very critical that you get the air cleaner either cleaned if it is serviceable, or replaced if it gets to a point where it is no longer serviceable. The other type of air cleaner is the oil bath type. Now, the oil bath type is a serviceable air cleaner that lasts the life of the vehicle. The air cleaner is serviced by cleaning it, and it consists of a container that has oil filled to a prescribed level, as you can see here. Above the container is a sieve that has several slots that allows air to pass, and on top of it is a wire gauze similar to a rough coarse steel wire that surrounds the air cleaner around. So this air cleaner is cylindrical, and then in the middle is the main air tube. So air comes in as the pistons are moving up and down. They draw the air from the atmosphere, and the air is sucked in through the gap left between the lid and the outer housing. The air comes in and is intentionally forced to change direction from the design here. Now, due to centrifugal force, the heavier particles of dust are thrown out of orbit, and they find themselves deposited into the oil bath that is below here. Then the air that remains has fewer dust particles, which then pass through this perforated sheet and enter the wire mesh that is also soaked in oil. Now, oil becomes very sticky, and it traps the dust particles that are in the air, and it allows the clean air now to pass through the gauze up here, or the perforated sheet, and enter the engine, and you get clean air. Now, it is very critical that once the service period is reached, that this air cleaner as well is serviced. And by servicing it, it means that you remove the top lid, you remove the wire gauze that is cylindrical, and you clean it in petrol to make sure that all the dust that has settled inside it comes out. And then you empty the oil in the oil bath, and below on the bottom you find mud or particles of dust now that are formed up. You scrape them out, you clean the container, and then you fill it with fresh engine oil to the prescribed level, and you drip some oil onto the wire mesh, and you return the air cleaner. And if this air cleaner is maintained well, then it should last the whole life of the vehicle. Now, lastly, I want to talk about the exhaust systems. Now, all road vehicles by law must be fitted with efficient silencers. This is because the exhaust stroke emits a sound wave composed of higher and lower frequencies of compression vibration. Now, the lower frequencies are resonance, while the higher frequencies are the vibrations that are generated due to the speed of air as it changes or as it moves out through the exhaust system. if you are to put a straight pipe, there is also the reason that the air flowing out of the engine would flow too fast and cause the engine to consume more fuel. And how is that possible? The exhaust system should ideally create a back pressure so that as the air is leaving the engine, the inertia generated by the air leaving the engine is dampened by the resistance in the engine, so that the fresh charge coming in cannot find its way out during overlap and escape with some fuel particles. That is why that the vehicle with a broken exhaust will lose power and also consume more fuel. Now, there are three types of silencers. There is the absorption silencer, the expansion silencer, and a combination of the two that is called a composite silencer. Now, the absorption silencer makes use of a straight pipe that has perforations, and around the pipe is a form of insulation that can be wire or glass wool. Now, what happens with the air? As the air is passing through here and it has its resonance or its pulses, the air leaks through the pipes or the perforated pipes, and as it enters here, it finds this form of insulation or the jacket, and this jacket helps to dampen those pulsations. And as the pulsations dampen down, the air falls back to the hose and flows through the exhaust, coming out quieter. The alternative would be the expansion silencer. Now, the expansion silencer allows the air to expand by giving it extra room and extending the length through which the air flows. So if you look at here, we have one pipe here, and we have backing here that forces the air to take a corner, take a longer route, keep expanding to the spaces here, and expands again into this space, flows over to the other side, expands again to the next space, and then finally expands out to the outer tube to leave the cylinder. This expansion allows the air that is coming in through pulses to dampen down and become relatively quieter. Now, if you combine the two silencers, then we get what we're calling a composite. You have the first side or the first length of the silencer being an absorption silencer. You have the perforated pipe and the absorbing material, but then we decide to add another column of an absorption silencer, and lastly we have a third column. So by having the three columns, we're also increasing the length of the air, of the length that the exhaust gases take, and give them a chance to absorb. So this makes it more efficient and makes the engine quieter. Now with that, I would like for you to read further on this topic and make sure that you try to attempt the questions that you find in the next past papers that I will share. Thank you for listening.